to you that the Space Inspire journey has begun. Space Inspire is the name of our new satellite that we will present to you today. So I will make this presentation with Pascal and Didier, who will go in depth and in detail in the presentation of this product. As far as I am concerned, I would like just to draw the context of this, the launch of this product. So, if we want to understand something, obviously we have to go back to the market of our customer, the satellite operators. And you see on this slide a summary of this market. So the first news, and those are, as you see, source EuroConsult. So those are official data of EuroConsult. It's not Thales Alenia Space data. So the first very good news is that you see that they forecast a growth of the market, 5% CAGR between 17 and 27. So this is the first news, and I think that most of you know already this information. The second important information in this slide is obviously that there will be a big shift in terms of the market segments that build this market. As you can see, and it has started since 1 or 2 years, the segment of video broadcasting will shrink in the future. And we know that it was the biggest, in the past it was the biggest segment. But the good news is that it will be compensated by other segments that will drastically grow: consumer broadband, mobility, and enterprise networks. So I think that obviously I don't have to describe those two segments, or 3 segments. You know exactly what I am referring to. So if we look at those 3 segments, there are 2 words that characterize those 3 new segments. Those 2 words are power or volume of the satellites that will serve those segments, and flexibility of the satellite that will serve those markets. So based on those 2 words, powerful payload and flexible payload, we have tried in Thales Alenia Space to anticipate what we see on this chart in order to better serve the market of our customers. So what did we do in order to address those challenges? We started in 2013, so 6 years ago, to make this analysis, and it was obvious for us that we had to invest massively in technology, in R&D, in order to be a market leader in this field. And once again, to anticipate the shift of the usage of satellites for our customers. So since 2013, we have invested more than 300 million of self-funded R&D on different products that I will present now. I have to say also that we have been accompanied in this journey by both the European Space Agency and some domestic European agency, and especially CNES in France. And I think that, yes, Lionel Suchet, head of CNES, is here with us today. Thank you, Lionel, to be there. But we have made those investments alongside with ESA and CNES. So the first step of our investment of the rocket, if I may say, in our market, was SpaceBus Neo. I think that you all know SpaceBus Neo. So it was a brand new platform which covers all the spectrum of needs of our customers, from very small satellite, very small payload of 3 kilowatts, up to very big satellites and payload, up to 22 kilowatts. So we designed, our engineers have designed a very modular satellite. As you can see on those images, it's kind of Lego, where you can build, or it's like a building where you can have different numbers of floors, 1, 2, 4, 3, 4, 5, 6 floors, and you build a very modular satellite. Obviously, another important topic of SpaceBus Neo has been the change of the propulsion that we made as other manufacturers from a chemical propulsion to an electric propulsion, allowing to gain some weight and giving more space for what is important on a satellite, which is the payload. And this SpaceBus Neo, and especially the big one, which we call SpaceBus Neo 200 for satellites over 12 kilowatts, was perfectly fitted to accommodate what we have called VHTS payload, and that we started to develop 3 years ago. Once again, with the support of ESA and CNES. On those, it was the first step, to have a very powerful payload. Through a first step of digitalization of the repeaters, not the antenna, but the repeaters, that enabled us to reach very high performance, because we are speaking here of satellites of hundreds of gigabits, as you know, and we have been very successful on this with this payload because we sold it to the major operators, starting with SES, and afterwards Eutelsat with Connect VHTS, and lately, this year, 2 months ago, we have been awarded a VHTS satellite with near the Indonesian operator PSA. But obviously, those satellites with this VHTS payload was just the first step towards flexibility. I remember the two words, power and flexibility. So power, we reach it with those VHTS satellite up to 500 gigabits. But in terms of flexibility, it became clear to us 2 years ago, we started those parts, that we had to propose to our customer a new satellite that will answer to the huge uncertainty about what will be the size of all the new segments that I have presented on the first slide. It was very easy when there was only one segment, broadcast, TV broadcast. Now that we have several segments and several applications, to be sure of the growth of each segment is not so easy. and all our operators were facing this uncertainty. This uncertainty, by the way, is the main, if not the only, the main root cause of a downturn of the market in 17 and 18. You know that less than 10 satellites have been ordered worldwide, and the reason is that all the operators, including the big ones, were in a wait-and-see approach or attitude, waiting for the satellite that will answer their needs and that will cope with this big uncertainty feature. And this satellite is called SPace In-orbit, which is the first fully digital satellite and payload. That means that not only we have digitalized the repeaters, but we have also digitalized the antenna, and we have a fully active antenna. So all the payload is now a digital payload, enabling this total flexibility, but it will be detailed in much more detail. It will be much more information by Didier and Pascal. So let's have a look to SPace In-orbit. Okay, so now I leave the floor to Pascal.
Thank you, Jean-Loic. I think we'll have to figure out why we did not have the sound, because it was supposed to be music altogether. But I think we'll redo it. That will be an occasion to show you again the video. So hi everyone, my name is Pascal Homsi. I just joined Thales Alenia Space about 4 months ago to take over from Leonardo to manage the business line telecommunication. So let me maybe tell you more about what market we are facing and why there was a need to have a satellite like SPace In-orbit. So our customers today are facing changing markets. So capacity price has dropped by about 85% in the last 10 years. There are new applications appearing like mobile connectivity and IoT, which is changing completely the picture and the paradigm. Non-linear television usage is also changing the habits with the introduction of IPTV. New actors are appearing on this market. So all this is changing the life of our traditional satellite operators. So they need to prepare the migration from the traditional pure broadcast to a mix of services, including, of course, broadcast, but also broadband connectivity. So, what does that mean in terms of a way of thinking? So, the market needs now new and cheaper capacity to accommodate this situation. So, satellite operators are less adverse today to risk-taking and are more embracing innovation as compared to before. All this to adapt to this changing environment to capture growth. So they want to seize any opportunity, anytime, anywhere, as it appears on the market. Obviously, they want cheaper solutions. So all the discussions we had recently in the last 2 days with our customers are showing this requirement. They need flexible solutions to carry satellite services into their infrastructure. So SPace In-orbit is a breakthrough innovation which is cost-effective and fully flexible satellite that is introduced today. So a word about the main benefits for our customers. Essentially 3 topics: optimized usage of assets, unprecedented economics, and business efficiency. So we have designed the Space Inspire product line around those guidelines. So if I zoom into the first one, optimized usage of assets. So Space Inspire will allow to adjust coverage, to manage frequency plan, to dynamically allocate the needed power, concentrate the service on specific areas as demand requires, improve the overall system performance, but also importantly, easily expand the capacity with collocated satellites. So satellite operators will be able to increase salary capacity with this new range of products, will better manage quality of service, and will be able to provide specific services or new services along the lines. Next topic about unprecedented economics. Space Inspire will be produced in series, unlike the previous generations of satellites. It will help automate operations for the satellite technicians, satellite operations technicians. The satellite mass will be reduced. That's important for our customers. It will allow progressive deployment of gateways as capacity increases. And it will also enable to deploy less but more capacity gateways. So our satellite operators will get satellite delivered faster. Space Inspire will, of course, reduce the total cost of the entire system. And at the end, will help improve and facilitate the operation of the satellite. Third important factor, the business efficiency. So this range of satellite will allow to relocate the satellite. If you don't need it anymore on a given spot, then you can remove it. Or if you can anticipate the demand, you can launch it on a given position and then move it later on wherever needed. Second, it will allow to reconfigure the satellite while in orbit. So the mission itself can be reconfigured. And finally, we will be able to collocate satellites, so 2 satellites, for example, at the same position, to increase capacity as demand requires. So the benefit for our customers, essentially, as an example, overcome incapacitated or overloaded hubs. It will increase the service availability all over the place. It will allow to provide new services, so even services that were not imagined at the time of the launch, so whenever needed. And it will expand the business capacity of the satellite. So, I'm missing a slide. Oh, sorry. Just wanted to introduce this slide before Didier takes over. We used to have one-off projects or designed to the need projects. That's the traditional way of doing the satellite business up till now. We have looked at the market drivers that this industry is facing today, but there are a number of techno enablers that are coming at the time of those challenges, like full mission digitalization or platform which is software efficient. This will lead us to have actually in the future most likely 2 categories of projects: the traditional ones, which are the projects that we tend to deploy as we sell satellites today, and more off-the-shelf software-defined products, standard satellite, I would say, predefined in terms of capacity, but which enable to introduce a service in a faster way. Obviously, the off-the-shelf satellite will, of course, be based on a number of off-the-shelf components, and Didier will tell you more about now how the Space Inspire has been designed and what it is containing, what it's all about. Didier?
Merci Pascal. So, full flexibility at an achievable and very affordable cost. Full flexibility existed some years ago, but was designed for military spacecraft at a very, very high price. So putting that at a cheaper cost compared to existing satellites was really a challenge. And we had to rely on three pillars. One is a standardized product. The second one is a fully reconfigurable solution in orbit, and the third one is to make it friendly to use by customers. We will come back on the following slides on these three pillars. The first one is mainly a way to transpose to geostationary market what we achieved for Iridium. By building a small series of identical spacecraft, we really realize this effect of savings, and we intend to make our customers benefit from these savings. For the full in-orbit reconfiguration, it has been explained already, we'll come back again on that, and we also discussed about the friendly user operation on the third slide. So this is, I believe, the first time we released a view of this Space Inspire product under a large configuration with a batch of 3 satellites. As you see, it's a quite tall spacecraft because we have a wide fairing that we can use to benefit a large surface. There is a lot of room to put antennas, and this is driving the performance of the product. This is a medium range satellite in terms of positioning, but it's very powerful. It's a 15 kilowatt spacecraft because digitization has a cost in terms of consumption, and so you need to cope with that by having been quite generous in the power you offer to your customers. It's based on active antennas, and this is enabled by the evolution of microelectronics. SPace have now an efficiency that enables this to be very efficient. It has been cyber secured by design because these assets should not be vulnerable at all. Our customers invest in these products, and we have all the strengths of the Thales Group to ensure that these products, despite the fact that there is a lot of software inside, will not be fragile at all. It's based on a digital transparent processor. We already have on the market today the most powerful transparent processor, flying on the VHTS products. This was dealing perfectly on the repeater side, and as Jean-Luc explained, we moved this digitization down to the beamforming of the antennas. This means that the antennas will generate thousands of beams that you can point and steer individually. You can change the shape, and you can change completely the power in each of the beams thanks to a powerful power bank. This power bank is just a range of amplifiers that you can run in parallel, and you decide by configuration to put more power where you have more user and more revenues for the operator. And the fact that this product is standard, you can launch a production rate. It's the same product for Ku-band and for K-band. We made a lot of thinking on the 2 years of design phase in order to have exactly the same, except the very final RF bar that is customized to Ku or Ka. So the product line can indifferently produce the 2 types of spacecraft. Here is a batch of Ku and Ka, and you even don't see the difference. And this enables you also to deliver it quite fast, in 18 months, and to reduce the cost for the customers. So if we jump on flexibility, the flexibility you have in the spacecraft is absolutely huge. First, you can shape the antennas. The example was taken, I believe, by Pascal, on the fact that you could decide to launch the spacecraft in Europe, and you know that ITU is regulating what you have the right to do and not the right to do. And it was a nightmare for our customers to try to move a spacecraft from US to Europe or vice versa, just because the frequency authorized are not the same, the polarization are not the same, and it was really a big constraint in their fleet operation. With this kind of spacecraft, you can change the coverage to adapt to any kind of continent, but you can also change the frequencies. You can avoid the forbidden bands. You can adapt the polarization from circular to linear, and even tilt the linear polarization, which is quite unique. We didn't know at the beginning that we would make it, but it's done, it's solved. And last but not the least, you can also change the positioning of the gateways. When a customer decides to launch a project, at the very beginning, he maybe does not know where the fiber optics will be. He has a difficulty to place the gateways on the ground. With this technology, it can launch the satellites and even decide after where the gateways will be. And this is based on a patented design for the gateway antenna that enables to have up to 8 mobile gateways with very good performance because there is a large reflector antenna to deliver that. And we believe this is quite unique. Then, as the satellite is providing a huge amount of flexibility, there are millions of degrees of freedoms that satellites can provide to the customers. We need to assist the customer in that. There is a complexity that needs to be supported by software on the ground, by some artificial intelligence. So in parallel with the hardware, we develop also the software. The first and obvious things to do is a dynamic control of the satellite and dynamic optimization of the resource in order to make it easy for the operators. We have decided also to build, each time we build a spacecraft of this Inspire, we will build a digital twin of this Inspire. So this digital twin will be born at the same time of the real hardware. It will be upgraded over life with all the data coming from the tests. It will follow the spacecraft in orbit. If there are some evolutions of the performance, this digital twin will, in a unique place, consolidate all the data of the spacecraft and can be used to optimize the capacity. It's a digital way to do that. And this product will drive our customers to also evolve in their own digital transformation. And we even have predictive analysis because some things are predictable, both traffic evolutions over time, like the planes, or even rain fades can be monitored, and you know that the rain will come on your gateway. You can anticipate that to have a very, very smooth operation. So in a nutshell, in order to leave you the floor for the questions session, Inspire is a game changer. We expect that really to modify the market and the way the satellites will be operated by our customers. It's fully reconfigurable. There is an automated system for management. It really disrupts the capex that our customers are used to, because it's bringing a series effect into a geo world that was made of one-off projects. And it's really open to new applications, just like a return channel on a TV to monitor what the customers are doing to improve security or to do a lot of things that maybe we have not invented today. That's it, and the floor is yours for the questions.
Before starting the questions, we had an issue